Hello everybody, welcome to my YouTube video about the planets for the rest of 2020. I put this together because I did a little bit for the Virtual Astronomy Club last night, so I thought I would put together just a video on the planets themselves and had a few more bits I didn't include last night. So what have we got to look forward to? Of course, 20th of July we had Saturn at opposition, because if you go out just after it gets dark, if you look towards the south and slightly east, you should see two bright stars down there. The really bright one is Jupiter, of course, and the one to the left of it is Saturn. So they're the two major planets in the solar system, the biggest planets in the solar system, almost side by side. And of course, they're going to get closer together throughout the year, and we'll talk about that a bit later. A few days around opposition, the rings actually brighten because of the direction the sunlight's coming onto the particles of the rings, and this is called the Seeliger effect. And here's the rings, here's Saturn, and you can see that's an image that I took on the 7th of April. But if we compare it to one that I took in June 2018, you can see that the rings are actually starting to close up. You can see a gap, which is called the Cassini division, in the two main rings, and you can see the disk of the planet, and you see that the rings actually appear beyond the north pole of the planet in the image. But this year, 2 years later, you can see that the rings have actually now below the disk of the planet. The disk of the planet is actually above the rings, so the rings are starting to close down. They're going to get thinner and narrower as time goes by. And that's called the Seeliger effect, which is the brightening of the rings. And of course, as I said, the angle of the rings are narrowing. Here's a little bit of a better image, a little bit noisy image that I took on the 7th of August, which shows it a little bit clearer. Still a bit of noise there, and I'm hoping to improve on those as time goes by. We'll see. They're not easy, and I'll talk about that a bit later. On the 14th of July, Jupiter was at opposition. And of course, here's a picture of Jupiter. And if you've got a pair of binoculars, have a look at Jupiter, because you will see up to 4 bright objects really close to it. And they are the 4 main moons. And I'll show you an image of that right at the very end. But you can see some of the features on here. You can see the dark belts and the bright zones of Jupiter. You can also see the red spot just about to disappear off the edge of the planet. And you can see this dark barge here, what they call a barge. Okay, so because we're looking with both Jupiter and Saturn, we're looking at gas planets. So we don't see a solid surface because they don't really have one. They just have these clouds that we see, these turbulent clouds that are forever changing. So it's always worthwhile keeping an eye out on them. 18th of October, Jupiter and Saturn, they're getting low down. They're now over towards the southwest, but they're starting to get a little bit closer together, and we'll talk about a little bit more a bit later. They're approaching each other as Jupiter overtakes it. Because Jupiter's closer to the sun than Saturn is, it actually moves along in its orbit faster. Saturn's moving in a similar direction in that direction, and Jupiter's moving in that direction, but because Jupiter moves faster, it's going to overtake Saturn and pass it later in the year. On the 14th of September, we got Venus, nicely visible in the morning sky. It's visible before sunrise in the morning sky for the rest, well, most of this year. So we've got Venus, the Moon, and the open star cluster Praesepe, Messier 44 in Cancer, visible on the 14th of December. So get out there before it gets light, and you'll be able to see the moon strongly moonlit, or earth shine, or shining on it, close to the open star cluster, and Venus just below that as well. So it should make a really nice photographic opportunity. There's Venus, there's Praesepe, and if we look a little bit closer in, you can see here's Venus, here's the open cluster of stars, and here's the moon shown at the correct size. In the previous one, it was shown slightly bigger to give you more of an effect. So get out there before it gets dawn on the 14th of September to see Venus, the moon, and Praesepe very close together. And then a month later, on the 14th of October, the moon's close to Venus once again as it comes through its phases. It's a little bit thinner this time, so it should have really, really nice earthshine. And it's a much darker sky because obviously we're much later into the winter. So we're really approaching winter now. So that should be nice to look out for. And then on the 11th of November, we got 3 objects really close together. We've got the moon, showing really, really thin with lovely bright earth shine on it. We've got Venus up and to the right, which is very, very bright, and you'll have to leave it until the sky gets a little bit bright like this to give you a good chance of seeing Mercury, which is much, much lower down in the sky and a bit fainter than Venus as well. So there's a challenge for the 11th of November, so get out there and have a look for those. Of course, all the excitement is on Mars this year. It's the opposition of Mars. The last one was 2 years ago because Mars comes to opposition on average about every 2 years. So here's the path in the sky. So you can see it's moving and it stops, does a loop, stops, and then carries on its forward trajectory again. This is something that the ancient people really couldn't understand because they thought that the Earth stood still, because that loop is actually caused by the Earth overtaking the planet as it moves around its orbit. So where's the planet? Well, on the 1st of August it was there. It's in the constellation of Pisces. On the 18th of August it's starting to slow down as the Earth starts to overtake it properly. And there it is on the 1st of September, really starting to slow down there. And then on the 10th of September, it's come to a full stop. So it's starting to reverse its speed and direction. On the 1st of October, and then on the 13th, 12th and 13th of October, it's close to this little cluster of galaxies. So that could be quite interesting to have a look at those and see if you can get a really long exposure to reveal all those little galaxies and the really overexposed Mars close to them as well. On the 11th of November, it's up here. And then by the 14th of November, it's actually stopped again. It's starting to reverse its direction and carry on in proper motion, because this part of its path is actually known as retrograde motion because it's going in the opposite direction to its proper motion. On the 1st of December, it's here. Middle of December, and then the 25th of December, Christmas Day, it's just to the left of this cluster of galaxies. So again, if you leave it about 23rd or 24th of December and have a look, have a long exposure, see if we can reveal all those faint galaxies behind it with Mars really overexposed. And then the 31st of December, that's where we find Mars. And of course, it carries on into 2021. So here it is on the 13th of October. It's highest in the south around about midnight, and you can see there's Mars quite nicely. It's going to be at magnitude -2.6. It's going to be really, really bright. It's also going to look very, very red as well. That's why they call it the red planet, of course, because it's covered in iron oxide or rust, and that gives it the red colour. It's in the constellation of Pisces, as I said. And here's what it looked like 2 years ago when it was last at opposition. Mars comes to opposition roughly every 2 years, and last time it was really low in the sky, roughly where Jupiter and Saturn are at the moment. This year it's much higher up in the sky, so we're going to get a better view of it. But not all oppositions are the same. When it was at opposition in July 2018, it was at its closest to the Sun. So that meant it was at its closest to Earth. So the disk was very big. But because it was low down in the sky, Southern Hemisphere observers got the best views. Unfortunately for them, there was a big dust cloud that year because it was a perihelic opposition. That means Mars was at its closest to the Sun when it came to opposition. At this time, there was a huge dust storm that built up, and it obliterated all the features. So they didn't really get a chance to get really lots of nice high resolution detail. Hopefully this time we will. So it's a lot higher in the sky than it was for us last time. And this time even though it's not quite as near to the Earth as it was a couple of years ago, here's the size it's going to be, this opposition. You can see it's not really that much different to what it was 2 years ago. So we've got a fighting chance to get some detail as long as this dust storm doesn't occur. And the chances are it won't. But hey, this is 2020. Anything could happen, couldn't it? Anyway, so this is an image I took on the 7th of April, so you can see how difficult that was. But because Mars changes size, as the distance between Mars and the Earth, it decreases, the size or the apparent size of Mars increases. So you can see by June, you can see it's much, much bigger than it was in January. So here's July and August. And there's an image that I took on the 8th of August. The polar cap was still really, really nicely there. And you can see some of the detail on the disk as well. So I was quite pleased with that at the time. Hopefully, I'm going to improve on that as we go through the season. And here's a mock-up in Stellarium of the same time that I took this image. So you can see some of these features you can see just on this mock-up. So I'm quite pleased with that. But hopefully I'm going to get a lot better as it gets bigger. And then September, October, you can just see how much bigger it is compared to what it is this month. Okay, so by October it's going to be a lot bigger, so we should get better resolution images of the surface. And then November and December, it's starting to shrink again, but it's still going to be bigger than it was in August by December. So, you know, we've got a few months to get some good images, and it being so high above the horizon, we should be able to do that. But the other thing to think about, when you're out looking at Mars, don't think to yourself, if you want to see a different part of Mars, go out the next day, because its rotation period is very similar to the Earth's. So if you go out at the same time on successive nights, Mars will have only moved a slight little bit compared to what it was the night before. So what you really need to do is to make a long session of it. Go out there, spend the whole night looking at Mars, and then you'll see the objects and the surface features rotate into view as it rotates. So have long sessions, make the most of it while it lasts. So here's a little animation I put together from 3 of my images from the 8th of August to try and show a rotation while I was out there for the couple of hours that I was taking the images. So let's look ahead to some of the other planets. Neptune is at opposition. It's actually in the constellation of Aquarius right there. Okay, so it's a difficult one. Mars is going to be here, so that's a lot easier, but Neptune is really, really faint. So it's at opposition on the 11th of September. So this is the view at midnight, looking towards the south when planets are at their highest at midnight. But it's going to be magnitude plus 7.8. So you are going to need binoculars or a small telescope to be able to pick it out as a small star-like point. But because Neptune is so far away, to actually see the disk of the planet and the bluey-green disk, you're going to need a telescope with fairly high magnification. But you can pick up the disk, and you can, if your imaging techniques are right, you can pick up its largest moon as well. And Uranus is also opposition. That's in Aries. And it's not far from Mars, and that's on the 31st of October. So again, midnight, and it's magnitude plus 5.6. So this means it's just above naked eye visibility. So you should just be able to see it with the naked eye if you've got really good eyes and you've got really dark skies. Binoculars will show it really well, and a small telescope should show you the bluey-green disk. Okay, it's also not far from some other nice objects. You've got the Pleiades star cluster here and the Hyades star cluster there. And of course, when you see the Pleiades and the Hyades rising at sort of midnight, and they're really high, fairly midnight, you know winter's definitely on its way. Especially look down towards the east and you see Orion lingering there waiting to take its place in the winter. And looking ahead, Jupiter and Saturn now getting cozy by the 1st of December. Here they are, you can see how much closer they are compared to what they were during September. So they are approaching as Jupiter overtakes Saturn. And then the last treat I have for you is on the 21st of December, when if you look over towards the southwest, you should see a really, really bright star. It's actually the two together. And this is the view around about 5 o'clock in the evening, and Jupiter and Saturn really, really close together. They're in conjunction, but they're really, really low to the horizon, so you need a really good southwestern horizon to be able to catch that. But give it a go. And if you've got a telescope, have a look, because this is the view you'll get. You've got Saturn here with its rings, you've got Jupiter, and you just see how close they look together. Of course, Saturn's much further away behind Jupiter, but that should be a great sight if we get some clear skies. So visible in a wide field, reasonably wide field. Binoculars should show that really well, and a small telescope should show it really, really well. And of course, don't forget to look out for the moons. You've got Io, Europa, Ganymede, and Callisto, and of course Titan as well, if you can spot that in the twilight. So there's another challenge for you. But all good fun. Okay, I hope you've enjoyed my run through where the planets are, and I'll just give you a few tips on getting the most from observing the planets. You do require a fairly high magnification, so you need to use the shortest focal length eyepiece to get the maximum magnification on any particular scope. If you've got a Barlow lens, use that as well, because that will increase the effective focal length of the telescope and give you higher magnification for any particular telescope. And an ADC, an atmospheric dispersion corrector, is really, really useful, especially with Jupiter and Saturn, which are really low to the horizon. I'll talk about that in a second. So, atmospheric dispersion. As light passes into the atmosphere, it splits the different wavelengths of light. So the colours separate. So this smears the image, and that makes it almost impossible for you to focus it. The lower down a planet is, the worse the atmospheric dispersion becomes. So the higher up the planet, the less atmospheric dispersion occurs. And here's how it works. So we've got Saturn up here, and the light coming from Saturn hits the Earth's atmosphere and enters. And because the different wavelengths are affected to different degrees, red light less than green, and green light less than blue. So they smear and produce this sort of image. If the planet is lower down in the sky, as it is here, it hits the atmosphere at a shallower angle. So it splits the wavelengths even further apart. So the images of the different wavelengths are smeared even further. So that blurs the image and makes it really difficult to focus visually and when you're taking images. But this can be corrected. So here's what we really want, and here's what we get. So we need to correct those two images to get that back again. And this is where the ADC, the atmospheric dispersion corrector, comes in, which is a fantastic bit of kit. It uses two prisms in there which oppose each other, and they're adjustable, so they vary the amount of atmospheric dispersion they correct for. So you can vary the effect depending on whether the planet's high or low in the sky. This brings the different wavelengths back together so that you get a crisp, nice crisp image, and the colours converge back to the focal point. But it will not correct atmospheric disturbance. Unfortunately, at our budget, we're not going to have the equipment to be able to get rid of atmospheric disturbance, but it will get rid of atmospheric dispersion. So this is the ADC itself. It's got a little bubble level on there which helps you get it level. And the way that works is, here's Saturn again, here's the light coming in, hitting the atmosphere, and it splits the wavelengths of light. It enters into the ADC, and if you've got the bubble level set, so it's set correctly to the horizon, and these arms are adjusted to correct for the proper amount of atmospheric dispersion, you should, if you put your camera or eyepiece here, you should get a corrected image and a crisper image of the planet, and it corrects the problem. So that's the ADC in effect. I hope you found that on the planets useful. If you have, please like the video. Please subscribe to my YouTube channel and see you online soon. Thank you.